A Nobel Prize winner stared at the raw data streaming from the farthest edges of space and delivered a warning that still echoes through every observatory on Earth. It's a different universe. The James Webb Space Telescope had just pierced deeper into the cosmic dawn than any instrument before it. And what it uncovered wasn't a gentle refinement of our models. It was a complete rewrite, written in light that had traveled for more than 13.5 billion years. When the telescope locked onto one particular patch of sky, it found a galaxy blazing at a redshift of 14.44, existing when the universe was only 280 million years old. Theory had predicted that such an infant cosmos would hold nothing brighter than faint sparks. Instead, this galaxy shone with 100 times the luminosity expected, its spectrum laced with unusual nitrogen enrichment that no standard generation of stars could have forged in so little time. The thing is, the early universe was supposed to be simple, barren, still wrapped in thick neutral hydrogen. Yet here was a beacon already burning hot enough to carve its own signature into the darkness. And it was not alone. Across dozens of other fields, Webb revealed an entire population of these luminous outliers, each one defying the timeline astronomers had trusted for decades. The growing chasm between prediction and observation left researchers confronting a single, uncomfortable truth. The infant cosmos looked nothing like what we had drawn on our chalkboards. It was busier, brighter, and far more chemically mature than the standard picture of gradual assembly had ever allowed. But the surprises kept arriving in waves. Astronomers soon catalogued around 70 dusty galaxies hovering at the very edge of the observable universe, each one rich in heavy elements, and churning out stars at ferocious rates barely a billion years after the Big Bang. Dust itself should have taken generations of stellar death to accumulate. Metals like carbon and oxygen were supposed to be scarce until much later. Instead, these galaxies were already cloaked in the very grains that normally signal billions of years of evolution. The models that once explained galaxy growth now stood silent because the data showed star formation and chemical enrichment racing ahead of every forecast. Then came another revelation that twisted the knife deeper. In a region of space corresponding to roughly 800 million years after the Big Bang, Webb captured the chaotic merger of at least 5 separate galaxies slamming together in real time. Heavy elements forged inside those colliding systems were being flung outward across hundreds of thousands of light years, seeding the surrounding void far earlier than any simulation had predicted. Collisions were supposed to be rare in the sparse early cosmos. Here they were commonplace, violent, and already reshaping the chemical landscape of entire regions. The universe, it seemed, had been building itself with a ferocity no one had imagined. These strange galactic spectacles did more than upend the story of how stars and galaxies formed. They sharpened an even older tension that had haunted cosmology for years, the rate at which the universe itself is stretching apart. For decades, calculations anchored in the cosmic microwave background had pegged that expansion at roughly 67 kilometers per second per megaparsec. Yet when astronomers measured the same expansion using nearby galaxies, Cepheid variables, and supernova, the numbers stubbornly refused to match, hovering instead near 74 kilometers per second per megaparsec. The James Webb Space Telescope was brought in to settle the dispute once and for all. It did the opposite. Working alongside its predecessor, Webb eliminated every possible source of observational error, confirming the discrepancy is real and even more pronounced than before. With systematic mistakes ruled out, only one path remained open: the possibility that we have misunderstood the fundamental machinery of the cosmos itself. The standard model, built on dark matter, dark energy, and a single explosive beginning, now faces a crisis that cannot be patched with minor adjustments. Something deeper is at work, and the data streaming from deep space are forcing scientists to consider explanations once dismissed as too radical to entertain. One of the most compelling of those explanations comes from a Nobel laureate who has spent decades arguing that what we call the Big Bang was never a unique beginning at all. Instead, he proposes the universe moves through infinite cycles of expansion, exhaustion, and rebirth. In this picture, the cosmos does not simply fade into a cold, empty eternity. It reaches a state where all matter decays into pure radiation, where space and time lose their familiar meaning. Then, through a mathematical transformation known as conformal rescaling, that featureless infinity becomes the dense, hot seed of the next eon. Our Big Bang is not the origin. It is a transition point, a handoff from a previous cosmic chapter whose faint echoes still linger in the sky. The evidence for this cyclic vision once lived only in theory, but recent observations have given it new urgency. In the cosmic microwave background, subtle circular patterns appear, hotspots roughly the size of the full moon that stand out against the smoother temperature fluctuations. These have been interpreted as the final signatures of supermassive black holes from a previous eon. Those ancient black holes, having evaporated through Hawking radiation over inconceivable timescales, would have released their energy into the fabric of the next universe. What we see as glowing disks in the microwave sky could be the last whispers of entire civilizations of black holes that lived and died before our own cosmos began. The probability calculations attached to these patterns once seemed outrageous. Today, with Webb revealing galaxies that appear far too mature for their age, those same calculations are starting to feel less like speculation and more like prophecy. The strange things the telescope has seen fit the cyclic framework with startling precision. Galaxies that grew massive and chemically rich in mere hundreds of millions of years look exactly like structures that might have inherited their starting conditions from a prior eon, rather than building from scratch in a pristine void. The rapid appearance of dust, metals, and supermassive black holes no longer requires impossible acrobatics within a single Big Bang timeline. Instead, they become natural leftovers, seeds carried forward across the conformal boundary between cosmic ages. The universe we observe is not isolated. It is the latest verse in an endless poem of death and renewal. To grasp how deeply these discoveries cut, we must return to the moment when the cosmos was still shrouded in darkness. Before the first stars ignited, space was filled with a dense fog of neutral hydrogen that swallowed ultraviolet light whole. No photon could travel far. Then the first generation of stars began to shine, their fierce radiation slowly ionizing the gas and carving out tiny bubbles of transparency. Models had placed the start of this cosmic reionization around 300 million years after the Big Bang, with progress expected to be slow and patchy. Webb has rewritten that chapter too. The same ultra-distant galaxy, shining at 280 million years, is already emitting intense ultraviolet radiation, strong enough to clear a vast ionized region around it. Lyman alpha emission, the distinctive fingerprint of energized hydrogen, streams toward us from an era when the fog should still have been impenetrable. Light that astronomers once believed would be trapped or scattered is reaching us loud and clear. The bubble of ionized gas surrounding this early beacon stretches across hundreds of thousands of light years, a feat that standard timelines insisted would take far longer to achieve. So what does this mean? Either reionization began dramatically earlier and spread faster than any simulation predicted, or the sources powering it were far more efficient than we ever imagined. Perhaps the intense ultraviolet came from dense clusters of supermassive stars, unlike anything forming today. Perhaps hidden at the centers of these early giants lurked black holes already devouring matter at prodigious rates. Whatever the mechanism, the fog lifted sooner, The light escaped sooner, and the universe became transparent on a schedule that leaves our textbooks obsolete. Each new Webb image adds another layer to the mystery. Galaxies that should have taken billions of years to assemble appear fully formed in cosmic infancy. Expansion rates refuse to reconcile with the early universe predictions. Chemical enrichment and dust production race ahead of every expected milestone. The more precisely we look, the more the standard story frays. And in that fraying, the cyclic vision gains strength. If our universe carries imprints from a predecessor, then the rapid maturity of these early structures is no longer a crisis. It is confirmation. The implications stretch far beyond astronomy. If the cosmos is eternal in cycles, rather than singular in origin, then concepts like a true beginning and an absolute end dissolve. Time itself becomes a local property, resetting with each new eon. The laws of physics we cherish may be inherited traits, passed forward in slightly altered form. Dark energy, dark matter, even the arrow of entropy could find new explanations within the mathematics of conformal geometry. What we have called the ultimate fate of the universe might instead be just another phase transition, another bridge to something beyond our current horizon. Yet the most profound shift is personal. We who stand beneath these same stars suddenly find ourselves inside a story without a first page. Our galaxy, our sun, our brief moment of awareness are not the climax of a unique explosion. They are one verse in a repeating symphony that has already played countless times and will play countless more. The atoms in our bodies may carry faint echoes of stars that died in a previous eon. The light we see tonight might have begun its journey not 13 billion years ago, but across the boundary of cosmic ages we can barely name. If the Nobel laureate's warning is correct, if the James Webb Space Telescope has truly shown us a different universe, then the greatest mystery is no longer how everything started. The greatest mystery is that it never stopped. The cosmos does not ask for our permission to reinvent itself. It simply continues, cycling through fire and silence, renewal and decay, forever. What does that truth do to the way you see your own brief spark of existence? Are we accidental witnesses to one fleeting chapter, or essential notes in an unending melody? The data are still pouring in. The debate is only beginning. But one thing is already certain. The universe we thought we understood has stepped aside, and something far older, far stranger, and far more beautiful is stepping forward to take its place. If these revelations stir something deep inside you, if the idea of an eternal cosmos fills you with awe rather than fear, then keep watching, keep questioning, keep sharing what you discover. The story is still being written in light that has traveled across eons to reach us. And every time we choose to look, we become part of the next verse.